Hello all, I think I am live now. Let's see if I am live. Let me verify first if I am live or not. Let me see. Uh, yep, I think I'm live now. Okay, great. So, what I am going to do today is I am going to tell you guys about the UART protocol. So, the UART protocol is, a very important protocol, and it has two it operates on essentially just two wires. One is TX and the other one is RX, and the third potential candidate for the wiring is the ground potential, which obviously has to be connected um, between the master and slave, since this UART protocol works on a master and slave concept. So we have to make sure that uh, only um, the ground potential has to be connected, and the in the UART protocol only two devices can work simultaneously, and you can only connect two devices to each other if you want them to communicate. There is no involvement of any other devices if whatsoever. If you even want to if you want to add a third device, it's not possible in a UART communication. So yeah, that's why we move to some other protocols. But obviously UART has its own pros and cons, but it's a widely adopted protocol, and there are very less cons about it. So most of the people even nowadays use the UART protocol. So yeah, moving into the detail, I think um, there is everything available in this book, and essentially seeing from this from the chapter 10, I think. Let's go to that chapter. First of all, let's explore it, and see if there's anything worth explaining. 259 and serial port. Yeah, so yeah, there is this explanation of how UART protocol works. Data transfer rates. RS-232 is essentially the same thing as UART protocol, but it's just um, uh, based on a different logic. So it is essentially the same thing, but just a bit of inclusion of some other electronic components. Um, so yeah, here we go with the first example of UART protocol, where the external frequency is 11.09592 megahertz, and we have to make use of the timer registers, and if you want to um, like receive some stuff, like after a certain amount of time we have to make use of timer interrupts and something, some other registers as well. But to make the UART operational, we only have to work with SCON registers, which is the serial port communication register. And here we go. I can see over here there is the program written which handles your communication. So yeah, over here it also makes use of the timer one. Let's copy this whole program and let's see how it works. This program essentially just transfers a in ASCII to 4800 baud rate to the UART terminal. Let's see how it works. Let me first of all create a new program. Let me turn it off, and now you can see everything. And on again. I'm not able to see this. Okay, all the way. Okay, anyways, I hope it's visible now. me change it. First of all, let me first of all just create a new project, and then go ahead from there. Now I can change everything, change now it's visible. Okay. Now I can create a new program, new project essentially. Let's name it UART UART program, and file name should be UART 89C51. Let's copy this file name and save. And now I think it's visible. 89C51. Here we go with the protocol. Oh, sorry, with the controller. Yes, I want it. Okay, yeah. Let me add another file. Let's go with assembly file, and let me do UART underscore 89C51 and done. And let's paste the program. Oh, I forgot the program. Let's paste the program from the book. Control C. I hope it's copied now. Yeah, exactly, it's copied. It's a lot more helpful in this case, when your program is already copied from the book. Let me change the frequency 11.0592, and let's enable the output. And now let's see what happens. Missing end statement. Yeah, obviously we are missing the starting and the ending statement. Let's include that as well. org 00h, and what else? The end statement. So here we go. Let's see. Target not created. There is a syntax error over here again. Yeah, obviously it is not an ASCII. Oh, still there is an error. Let me see what the error is about. Oh, I think this is the error. Yeah, exactly. So the commas were, they were the other type of commas considered considered a as something else. Whenever this thing is purple, it means that this is recognized as a string by this Keil environment. Okay, I have a bit of power loss over here, load shedding. Let me turn on flashlight, and yeah, here we go. Okay. So now what I'll do is, since I've already generated the file, I can now go to Proteus and simulate it. So let's go to Proteus, and first of all let me create a new project if I can. And yeah, obviously I can. So over here, what I'll do is I'll place the controller first, 89C51, double click it, and I hope it's visible. Yeah, it's visible. And afterwards, I'll place I don't think I need anything else. I need a terminal, and I can get the terminal from you know um, I think the generator mode, probably. I think this is the oscilloscope mode, so I can get the visual terminal from here. And let me connect it right here. The TX should be connected to RX, since we only want the data to be transmitted. What the hell is it? There's some issue with my Proteus. Yeah, now it's so TX in the RX, and essentially RX should be going to TX. And let me upload the program file over here. Go to documents, delete after stream, UR program, UR this thing, and over here 11.0.0592, and enter. Okay, Let's see how it works. Bismillahirrahmanirrahim. Yeah, we can see over here at least there is something's going on. And let's change the baud rate of this thing. We have to change the baud rate. Oh, it's not visible. Let me yeah, so double clicking this component, we can see the baud rate. So it's 4800 and enter. Now we can see A being printed over and over again. So we are successful for now. At least we're successful in creating this project. Let me now program the IC using the burner, and let's see how it operates. Let me take out the burner and connect it right into the port. It will take a while. uh, okay, so I have connected the burner. Let me connect the IC. Hopefully, yeah, so it's connected now. And I think right now it's very necessary to turn on the yeah. So um let me turn on the camera now. Yeah, so here we go. I have connected the IC, and let me upload the program. There's the burn right here. Okay, got it. What I'm going to do is I am going to utilize this thing, and over here I think it's better now. Okay, so what I am going to do is I am going to upload the program, load, and go to documents where my program is, and go to delete after stream, UART, and X file over here. Enter. Yeah, we got it. And now let's hit program, and hopefully it will work. Yeah, it is working. So we at least got something. Yeah, it is uploaded already. Great, it works. So let me take it out from here. Let's replace the burner, and now let's connect the IC over here. Let me also bring the UART module into play, because obviously we need a UART module. I am using a CP2102 based UART module, and you guys may be having some other modules. Let me connect. So we need the RX pin, which is yellow and black in my case. Sorry, yellow and brown. So let me connect it first. There is some issue with my camera. This issue has been there. It's the most recent issue with my camera now. Let me now connect the TX over here, and ground. I think now everything is connected. Let's get right to the business, and let me remove the burner for a while and connect the UART module instead. Bismillahirrahmanirrahim. And power up the circuit. Bismillahirrahmanirrahim. Yeah, there we go. So right now I've powered up the circuit, and hopefully I think it works. It works. Yeah, it is working. Let me share my. Let me turn on the cool term. I am using cool term software. Um, so let me turn it off. It is connected. I accidentally turned it off. Okay, now it's connected. Okay. Where it is? Walaikum salam, MBU. Okay. Let me just go to capture and name it as a cool term. And this issue still prevails. I don't know how to fix this issue, the camera issue. I am still facing it. Stupid camera. Okay, let me now select the border over here. Let's share this screen as well. Let's share it. Connection options. Okay, turn it on. So what I'm going to do is I'm going to select the exact baud rate, which is 4800 in my case, and turn this off. And yeah, there is nothing else, so I'm going to click OK. And now I am going to open CoolTerm. There are some glitches in the screen. Now the UART terminal is connected, and let me turn on the circuit. There are some power issues. Yeah, you can see over here A is being printed over and over again. So my UART program works. I have done this program in assembly language, and you can see my circuit is powered up. Everything works fine. So yeah, this was the UART program, and now I can change the program to just print something else maybe. um, and we can do it here. We can change this, we can write a string and load things over and over into this register. And for this, I think the best thing to do is to look into right into the book, um, because the book is where we can find some really cool examples. Yeah, you can see over here. Over here you can see um, the program where you can send yes to the UART port. Let me just now copy this thing. Let's see how it works. Let me copy it. I think it's going to work real well, but who knows? Let's test it out. Control C and copy everything over here. Control A, Control V. So I have copied everything now into my program. Sir, what your software are you using? I am using CoolTerm. I think you are sleeping in class, so that's why you're asking this stupid question. Okay, let me write org00h and add an end statement so it gets recognized. Yeah, let's try to. Oh, there are multiple syntax errors. Yeah, I know what the errors are because obviously I have told you about this. While copying from the book, there is this error which I have corrected in the previous program, and hopefully after doing this everything will work fine. And here we go. So it compiles well, and let's see if the simulation is better operational now or not. Let's see. Who knows? We have already changed the program. We just have to now change the baud rate. Let's see if we can change the baud rate. What I can do here is to you know just components. Yeah, here we go with the baud rate. Double clicking this virtual terminal, you'll be able to see the baud rate. And let me now select 9600 since we have written the program for 9600 baud rate. And as soon as I click this, you'll be seeing yes. It is real fast, and it's very hard for us to see. It is real fast. So let's upload the program to our IC, and let's see how it works over there. Let me now open burner and select the file again, the UART file. And I have already selected the file. Information is quite vague in my case. um Let me just connect the burner because it's not connected right now. Let's connect it first. I hope it works now. It better work. Okay, since the camera is off, there are just two USB ports in my laptop, and this thing is messy. It's messing everything up. Let me upload the new program. I hope I've loaded the new program. Otherwise, I'll be in a big trouble since I've already erased the old program. Yeah, it is uploaded now. Let me turn on the camera real quick. If I can, if I can, yeah, yeah, I can do it. Um, okay, got it. Everything well. Okay, let me just load up the IC right here. Oh, I am messing up the connections because my table is swinging everywhere, just not stationary. Okay, let me load up the. Let me turn on my controller, and here we go with the blinking. Let's connect to the CoolTerm software, and let's see how it works now. Let's change the baud rate to 9600 again. Once again, let me show you the terminal if I can. Connection options. Yeah. So let me turn on. Let me first of all let me select the baud rate. The new baud rate is going to be 9600, and for this I have to rescan. Rescanning provided me with nothing. How come? Let me reconnect it. Probably that's the issue. Rescan. Yeah, now I got it. Now I got it. Okay. Okay. Now, as soon as I turn this on, on. I hope it work now. Better work. Oh, oh, here we go. It's writing up yes and yes, 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 yes. Yeah. So here we go with the program. It's there are a lot of bugs. Uh, it's awesome to see your project working in real time. So yeah, I've made it operational just in front of you. Um, for now, I have only worked with the UART protocol, and writing the program in C language is much easier. Let's see in the book if there is any detail about it. Let me open book and let's see if there is anything in detail. Let's go to second page. Okay, what it says, program to receive. Oh, right here, the example number 4. It is the program to receive bytes serially. Assume is connected com board. Oh, okay. So you can go to this example, and it makes use of the data pointer. So in this program, you can essentially write a string on a certain part of memory, and the whole string will be read through the data pointer, and it will be loaded to the sbuff register sequentially. As I told you earlier, it's the same thing. Um, you can see all of the registers in detail, and play with the registers and stuff, and just to um, get a detailed overview of how things operate. Let me see if I can find any C language program of this of your protocol. If I can, only if I can. It's very hard for me to find this program, C language program. Yeah, here we go. Here we go. Now the same program which we'll use to load up a character on the terminal. It's the same program. You can just write it down. Um, you can check it out yourself. Let me use this program. It's the most important program. It's the same thing which we haven't done in assembly language yet, which I have told you about it earlier, that the data pointer thing, dptr command. It's the same thing but in C language. So let's see how it operates. um, Normal speed, high speed, we don't need that. Need a couple of okay. While it transmits a I need a program which tells me how to transmit a chunk of data. Ali Smith. Let's test this out. Okay, um let me close this book. This thing gets to be closed now, and let me load up the new project, and let's be real quick, because I don't have enough power, and my laptop is nearly shutting down. UART underscore 89351 underscore C. Yeah, 89351, and selection of the first program. Yes, I want to do this thing. Yes, I want to add this. And let's load up the C file, add a new file, and I want it to be C. What should be the name? UART underscore program underscore C, and write it down. Everything I copied from there, and let's arrange it a bit. It's so it's better for us to understand the long run. My laptop is nearly burning into flames. It's very hot now. It is burning real hard. I am really worried about how I'll carry this stream with this much, heat. It's heating too much. It shouldn't be heating this much, but I don't know, for no reason it's now heating up. So this program seems to be operating on a switch, on an input switch. I'll disable it. I'll disable this thing, and I'll disable this thing as well. A baud rate of 9600 seems to be okay. SCON TR1, and I don't want to check for the register, and I don't want to do it as it is. Wait for transmit, and yeah, here we go. I think this program is much better. Now what I'll do is I'll first of all, after transmitting all the characters, I'll let's wait for a while, and after waiting, let me see if I can do it. Yeah, I'll have to obviously add a wide delay function over here. Let's do that first. And ms, let me just uint 32 underscore t. Oh, it's not the same over here. It's probably unsigned int. Let me just write it quickly. And I comma j equals to 0, and this one is also equals to 0. I equals to I is less than ms, I plus plus, and I'm gonna create this thing through which I am going to create another loop over here. I'm done with the I. I am going to be doing now J part. Let's make it this way, J plus plus, and I think now, yeah, now we're better to go. Um, it's not going to be exactly 1 millisecond, but nearly the same. So let's not get let's not get right into the right into worrying about it not being 1 millisecond, and let's just um, believe in ourselves for now. Let me add a delay over here, and let me delay over here as well, which I think, to be honest, I think we can do it this way, where I can add a manual delay, lots of delay, and over here I'll have to include a uh, declaration as well. I hope it works now. Oh. Lots of errors. Okay, nothing to be worried about. Nothing to worry about. I think it's just small error. It's going to fade away. There is still, yeah, there is the comma issue. Let me first of all select the frequency 11.0592, and let me create the hex file as well. You might be hearing the huge fan noise of my laptop. It is very hot now, so that's probably one of the reasons why it's spitting so much air. Okay, now it should work. Now it should work. There is no reason for now for it to not work. Oh, still one error. Let's see what it is. Let's see what it is. There is one error which we got is equal to 0, equal to 0. Okay, okay. Let me do it this way. And yeah, now I think I'm good with it. This was the issue. Yep. Now it's linking and everything works fine. I hope, yeah. So we got 0 errors. Now I am going to see the simulation. Let me open Proteus and let's create. Let's upload the program first. The UART C. I have selected the file. The baud rate is already selected, and here we go. Moment of truth. Yeah, you can see Ali Smith being printed after a while. I hope it's visible. I hope it's visible. I hope it's visible. No, it's not visible. Let me share the screen. I thought it was visible, but not visible. GX540 full term. Where is the window? I cannot see a window. ZD and Microvision. No, that's not the file. Okay. Well, I cannot show you the output of the virtual terminal. I don't know why, but it's not showing up. Let me just upload the program to my IC, and let's not consider the Proteus simulation. Let me stop the simulation first. It will create a lot of junk in my RAM. My RAM is already preloaded, and it's just, my laptop is burning out. It's burning flames. UART underscore simulation. Let me save the file first. Yeah, it's already saved now. Let's upload the file. Go to burner and load up the file. It is UART underscore C in this case. Here we go. This is the file, the new file. Okay. And let's load up the IC if I can. Only if I can. Only if I can. Okay. Let's connect the G540 hardware.